Hey there, everyone. Happy Thursday. For today's climate lesson, we are going to go over Show What You Know number 3. It is useful terms and concepts. And so for this area of study, we're going to need to know some terms to understand what we're talking about during our discussions, right? And so what I would suggest, I sent you this and this through email. What I would suggest is I would print this side off. And then all these highlighted more like these blue words, I would write those blue words on a piece of paper like this. And then I would then marker or like take a pencil and scrape off and cover up those words, right? And then or maybe you have a piece of paper and you can like sit that piece of paper on top of it, and then you can test yourself. So you can read the definition and then ask yourself, well, what word would that be out of these? And that's what I would suggest doing. You can get your scientific journal out, and which is your green one, and you could write these down and record them. That is one way of going about it to help you remember these, or you could just read them. What I did is I typed up the words, and then I also typed up the definition, and I made a little game for myself. And so this is what that would look like if you were doing that. So I will do this first row and kind of show you how it works and how that would work and how to help you better understand these. So let's see. So the first one I have up here is adaptation. And the cool thing is, folks, as I did go in order of these, so as I read, you can also follow along with me. So adaptations. What is adaptations? The adjustments of living things to the environment conditions. Humans' adaptation to climate changes including altering the way they grow crops, building houses, consuming energy, and managing natural resources. And so what they mean by that, friends, is, over time things change. And so if it's not working anymore, we just don't, sometimes we'll stop doing it, but most of the time we change what we're doing so we can continue getting what we need. So for example, if we dig a hole and we find water and we keep taking water from it and the water runs dry, right? The hole runs dry. We're not going to just stop drinking water. We're going to adapt to what we're doing. We're going to change what we're doing to gather the water that we need to live. So adaptation, changing what you need to changing with what you need with the things that are happening in your environment. Carbon cycle. All right. The constant movement of carbon through living things, rocks, oceans, and the atmosphere. So the carbon cycle is actually what Miss Amanda was talking about today during her lesson. I thought that was really exciting because she kind of broke down exactly what the carbon cycle is. And so what she showed is that it's like this constant and continuum. So the animals give the input through their bone and output into the soil. The soil breaks everything down, releasing off the energy and things that the trees need, and the trees take in that energy and release out the energy that we need and the animals need. Is this beautiful cycle. And so it's the carbon cycle, right? Because they keep putting out carbon. That's beautiful, right? So that was really cool. So then that moves us on to carbon dioxide, a colorless, odorless gas that is naturally presented in the atmosphere. And so this is something that is constantly being represented. Our water does it, our animals make it, our trees eat it, they need it, but we produce that. So whatever you blow out, so you breathe in oxygen, you blow out carbon dioxide. So that's really cool, right? So it's something you can't see and it has no smell, but it's definitely there, right? Because think about it, guys, if you were to blow out of your mouth right now, put your hand in front of your mouth, you would feel air, and that is the carbon dioxide that you're blowing out. And then climate. Well, what is climate? The average long-term weather in a particular region. And so climate is something, it's a lot different than weather, because we also have a weather one on here. So here's climate. Climate is over long periods of time, right? Like over at least 30 years. But weather is something that is happening all the time. So the state of atmosphere, a particular place at times. So the difference between weather and climate are pretty different. And yes, they're talking about what it feels like, right? But climate is over a long period of time, at least 30 years. And weather is what's happening in the moment right now. So, for example, if I wanted to say, what is the climate of Indiana, we would say, well, it's Indiana. So actually you get all the seasons. It's very unpredictable because it has lots of lakes and rivers. And so that changes what kind of storms and temperatures that we get and the air fronts that move in. Where if I asked you what's the weather like in Indiana, I would say, oh, well, today I believe it is 68 degrees outside, sunny it is with a little bit of wind. And so that's talking about right now, today. All right. So that's the difference. All right. So here we go. Climate models. A computer program that enables scientists to investigate the many factors at work at the Earth's climate system. By multiplicating variables such as amounts of CO2 in the atmosphere, scientists try to understand how the climate will respond. And so these climate models are they're computer programs. They're constantly looking at the weather, trying to figure out how is this going to correlate to yesterday? How is this going to affect tomorrow? How is it different, last year? Things like that. It's to help better understand so we can respond. So to better understand tornadoes, to better understand hurricanes, to better understand all those types of storms and natural things that happen and occur, we'd like to better understand this to prepare, right? So when you're prepared, you can respond better. And so I know I said I would just do this first row, but honestly, I'm going to go ahead and keep moving forward because it's kind of nice to kind of talk about them and break them down, right, to help you better understand outside of those definitions. And so, for example, fossil fuels. Fossil fuels is coal, oil, and natural gas formed from remains of organisms and that lived millions of years ago. So we talked about fossil fuels last week. Fossil fuels are things that are from fossils, right? And they have to be there for a long period of time. And depending on what is created is depending on what kind of organism or animal or plant that was put there, how long, and what kind of pressure. So that all depends on what kind of fossil is made out of that. Global warming, an increase in average temperatures at Earth's surface caused by the buildup of greenhouse gases in the atmosphere. And so remember, greenhouses are good and we need those to have an atmosphere to be able to breathe and to be able to have what we have here. But if you ever have too much of a good thing, it never turns out good. Not enough or too much is still no good. Greenhouse effects. The process by which an atmosphere warms a planet. This takes place when gases allow sunshine to pass through the atmosphere but absorb the heat that radiates back from the surface, keeping it warm. And so this is what we were talking about yesterday when we got out the bottle and we talked about how this is the pitch that we did yesterday. We talked about the sun rays coming in at full 100%, but go through our atmosphere, taking away 50%, hits our surface and then tries to back out. But when it hits the greenhouse gases, it breaks it down. Only 30% escape and 20 bounce back in, keeping our Earth warm. But that is if that was a perfect cycle. It is constantly being changed. And so that doesn't always work, and that's how the greenhouse effect can be harmful because of the buildup of the gases. The more gases we have, the more heat that will be trapped in, right? And then right here it says gases that increase global temperatures by absorbing the radiation emitted by Earth's surface. Carbon dioxide is the most important greenhouse gas as far as the climate changes is concerned. Other greenhouse gases include water vapor, methane, and nitrous oxide. So there are a couple different there's many greenhouse gases. And like they said, the most popular one, the most important one is carbon dioxide. Now, another thing you want to take into that is carbon dioxide. That's everything that we always blow out, that the water makes, that we are making, that the animals are making. And so we're making it, but the plants are taking it in, but it also something that helps with the greenhouse effect. So that's just interesting to kind of noodle on and to think about. The whole aspect of the carbon dioxide cycle. Methane. And this is also colorless, odorless, flammable gas produced by various of natural resources, including microorganisms, cattle, and termites. And so that's pretty cool. So cattle, right? Cattle meaning cows. Termites are those tiny little small bugs. And so they're making methane. And this is also, again, this is, you cannot see it. It has no color. It has no smell. But this is flammable. So you can actually catch fire with this guy. That's methane. Methane. So, very cool, right? So, nitrous oxide. Let's read about this guy. Another no-colored gas, colorless gas, or liquid produced by a combustion pretty much as combustion. Sorry guys, I've had a hard time saying that word, of fossil fuel. And so, okay, another odorless gas. Okay, but I have a feeling, or not odorless, colorless. I have a feeling that one's got a smell though. Because it doesn't say anything about its smell. Oh, this word is cool. So this word was a new word for me. It's called paleoclimate, and this is talking about back a long time ago when we did not record our weather down, because I mean when you're first trying to just figure out how to feed yourself, you may not think, oh, I need to record down the weather for this region for my future ancestors. No, that's not a thing, right? You were going to be worried about your shelter, you're worried about just living, right, and being warm and feeding your belly. So a long time ago, back in the caveman days, we did not record weather. And so we had to go off like what we found in our land, like by digging down in the supplement and actually looking what was left behind. And so paleoclimate is the past climate before humans started measuring and recording it. And so we can only go back so far until when humans did start recording, but there was weather before we started recording. And so when they ever do that, they'll talk about the paleoclimate because that is time before we started recording. All right. Parts per million, ppm, right? Parts per million. Now, this is a unit used to measure concentrated of trace gas, combinations of trace gases. Values refer to the number of specific molecules contained in 1 million molecule of dry air. And so contained in 1 million molecules in one dry air. Holy camole. And so what they're doing is they're looking at one particular part, like so they'll have gases and they'll look at one particular part of so we have a bowl of gases and they'll look at one area and they'll say, okay, how much is in that spot? And that will help decipher how what's going on in that mixture, what could happen with that mixture, if it's combustible or whatever. And so parts per million. Very cool. All right. Permafrost. The prematurely frozen layer in soil beneath the surface of the cold regions. And so there is a layer in our land that is completely frozen, and that's what this is talking about. There's a permanently frozen layer of soil beneath the surface in the colder regions. And so that's an area of which scientists are constantly observing to keep track to see how is it going, what's going on, and that's an area that we could be looking at as well during this study. Photosynthesis is the beautiful theory, is the beautiful process of which how plants take in the sun's energy and then produce their sugars to feed themselves and also give off the oxygen to feed us. And so photosynthesis is that beautiful process, right, of the green plants using sunlight and for food and all that good jazz and creating oxygen for our atmosphere. Photosynthesis. It's a beautiful process, and without it, we would not be here. So thank you, photosynthesis. All right. So this is the process of when living cells that release CO2 in water when organic compounds combine with oxygen and break down. Respiration. So the process of living cells that release CO2 in water with organic compounds. Okay. Now, this one, the water cycle. We've talked about this one when we were doing oceanography. The water cycle is really beautiful, and it's about how the water goes and because water it can do so many different forms. It can do liquid, it can do gas, it can do solid. And so the fact that HO2 can do that, right? The water can do all of those forms. The water cycle is just so beautiful. And so again, without that water cycle, our world would not be the way that it is today. So it's a very important process that the world does. Water vapor. The genuous or the gaseous state of water. So water vapor is kind of how the water is a part of the water cycle. And it's when the water goes from a liquid to a gas. And then we've already spoke of weather. And so those are those folks. And so that's something that you can do. Like I said, it's not, it's not a science experiment. So it's not going to be, fireworks going on. But it is really cool to understand these words and to better get more comfortable with these terms. So then as we're talking about them during this unit of study, you're not going to get tangled up then with the terms. And if you better understand the terms, you won't get tangled up in the terms. So what for the show, what you know, it says, please choose 3 terms to record with their name and corresponding definition in your science journal. And then please, after you recorded 3 of them, you would make 1 sentence with 1 of the words. So that's pretty cool. All right, folks. Well, I hope you have a great Thursday. And we will have 1 more lesson tomorrow, making a terrarium. I'm super excited to do that with you guys. But that is a lesson for another day. So I hope you guys had a great Thursday, and I will be on here tomorrow. Bye for now, friends.